Layers of the atmosphere. The layers of the atmosphere perform a number of activities that make life possible on Earth. Apart from having life-sustaining gases such as carbon dioxide and oxygen, they determine weather patterns and protect us from harmful solar radiations coming from outer space. If a vertical analysis of the atmosphere is made in terms of its composition, pressure, and temperature, starting from sea level going upwards, a number of characteristic layers can be identified. These layers are illustrated by the table and figure below. If we look at this figure here, we can see that this here is the Earth, and just above that is the first layer that has been identified. It's called the troposphere, followed by another layer, stratosphere, the mesosphere, and then the thermosphere. This table here shows three features about each layer. It gives the height of each layer above sea level, and the pressures and temperatures read within each level. So if you look at the first layer here, that is called the troposphere in terms of its height above sea level in kilometers, it is 18 to 20 kilometers, and this is measured at the equator. This troposphere here, the height of its troposphere above the Earth's surface, changes across the Earth's surface. For example, it is less at the poles, okay? So at the equator, it measures 18 to 20 kilometers. This is the stratosphere here, and its height above the Earth is 50 kilometers, followed by the mesosphere, which is 80 kilometers above, and the final one, which is the thermosphere, which is 120 kilometers above. The pressure experienced in the troposphere is 100 kilopascals. Pressure in the stratosphere is measured to be 0.1 kilopascals, and that in the mesosphere is 0.1. You can see how small it is in the thermosphere here. One might want to ask, why is it that we have this drastic decrease in pressure from the troposphere to the thermosphere? Now, if you look at these arrows here, the length of these arrows here represent the column of air above the Earth's surface here. Note that the troposphere has the majority of the gases in the atmosphere, about at least 75% of all the gases that are found in the atmosphere are in the troposphere. So one can now understand why the pressure read at this level here will be much less than this one here, because look, the amount of gas that's present now in the atmosphere is so much less than this one here. And of course, this one and here is nearly the same, and that's so small here. So as you move away from the surface of the Earth going upwards, especially away from the troposphere, the pressure gets less and less, and of course the air gets thinner and thinner. Okay? In the troposphere, the temperature ranges from negative 67 degrees Celsius to 35 degrees Celsius. In the stratosphere, it ranges from negative 67 degrees Celsius to negative 2.5 degrees Celsius. There's an increase here, and you can see in the mesosphere, it changes from negative 2.5 to negative 85 degrees Celsius. And of course, you see is a big jump from negative 85.5 degrees Celsius to 1200 degrees Celsius. Okay? We'll read for you some characteristics about the troposphere, and then we use the figure below here to talk about how energy is moved around the globe by air currents and stuff like that, and to explain to you why troposphere means change. The troposphere, which means change, is where we live, and it contains 75% of the gases present in the atmosphere. It has 99% of all the water present in the atmosphere. The heat trapped by the Earth, these what's called heat sinks here, water and land, from the sun is radiated back into the troposphere and warms it up. This is where mixing of warm air and cool air happens. Warm air rises and cooler, denser air sinks. These movements help to distribute energy over the Earth and produce different weather patterns. Hot air balloons operate in the upper part of this layer to monitor weather changes. As one ascends the troposphere, the air becomes much thinner at extremely low pressure. The tropopause is the transition region between the troposphere and the stratosphere. So this figure here helps us to understand how energy is distributed in the troposphere. So first of all, let's deal with these transition areas here. This white region here that separates the troposphere from the stratosphere is called the tropopause. Then here's the stratopause that separates the stratosphere from the mesosphere, and then you have the mesopause, which is a transition region between the mesosphere and the thermosphere. So this is what these white regions represent. Of course, now this is the Earth here, and you have these heat sinks here, which are the land and the water. During the day, they absorb radiant energy from the sun, and they are heated up. Now, what happens, especially at the equator, that is very hot, the air in the troposphere absorbs energy from these heat sinks and rises. As the hot air rises, it creates low pressure here, and the cooler air sinks to fill those areas where low pressures have been created. These movements here create air currents and different types of weather patterns. Also, these movements of the air, along with the moisture that they take, transfer energy over different parts of the globe. The point we want to note here is that changes are taking place within the troposphere. That's why it's called troposphere, which means change. Meteorologists insert hot air balloons in this part here, where all these changes are taking place. And these hot air balloons have instruments to measure pressure, temperature, humidity, and wind speed. And the information gathered is used to make weather forecasts. Okay? So that is the point about this diagram here, is to explain to you how weather patterns are created here, okay? And how they are being monitored by these hot air balloons. Point to note also here is that just above the troposphere is this layer of ozone that we'll talk more about in the next diagram here. We will read for you, before we come to that figure there, what a stratosphere is all about. Of course, it means layer. It means layer because within the stratosphere is a layer of ozone there, along with air. So we say the stratosphere experiences some degree of warming from infrared radiation flowing upwards from a warmer troposphere and UV coming from above. The energy absorbed from UV along with infrared radiation from the troposphere are what raise the temperature of the stratosphere from negative 67 degrees Celsius to negative 2.5 degrees Celsius. And since this warmer air sits on top of denser air, so in this case, we'll explain that just now. Warmer air sitting on denser, colder tropospheric air, no mixing happens. This is similar to what happens when there is an atmospheric inversion in the troposphere. Very little disturbance in weather patterns happen in this area. Because of that, pilots make use of this stable feature to fly there. In this layer is found the ozone layer. We alluded to that already. And is about 20 to 30 kilometers away from the surface of the Earth. The ozone layer is important since it blocks UVB from reaching living organisms on the Earth. The stratopause, spoken about that, is the transition region between the stratosphere and the mesosphere. So we go back to look at this figure here. There's lots of information are embedded in this. So we'll try to explain to you now why we have these different temperature ranges within these different layers. So go back to these heat sinks now. Land and water absorbs energy from the sun, and it raises the temperature of the air inside the troposphere. You can see just above the Earth's surface here, the highest temperature, well, average highest temperature, is about 35 degrees Celsius. And as you move farther away from the Earth's surface, the lowest temperature that's reached by the troposphere is negative 67 degrees Celsius, okay? Then we come now to this stratosphere here. The stratosphere, you can see, has a temperature range of negative 67 degrees Celsius to negative 2.5 degrees Celsius. How does it attain these temperatures? One, it is from the infrared radiation that's coming from the troposphere into the stratosphere. All these red arrows indicate that, infrared radiation. And secondly, UV. The UV that comes in is blocked by the ozone layer there. And in blocking the UV, energy from the UV is retained by the ozone layer. And these two sources are what give the stratosphere that temperature range here. Negative 67 to negative 2.5 degrees Celsius. Okay. The mesosphere shows a decline in temperature from negative 2.5 degrees Celsius. It goes down to negative 85.5 degrees Celsius. Here it is said there's very little greenhouse gases to absorb energy from the sun, and the only energy that comes, probably it comes into it, is infrared radiation from the troposphere that makes its way into the mesosphere. Okay, that is why you find that there's a decline in temperature there. Okay, then of course the thermosphere is very, very hot because it's a direct impact of energy, solar energy. Most of the energy is absorbed here before it reaches down here. Why is there stability in the stratosphere? In the troposphere, look what happens. Normally in troposphere, you have hot air is rising and then cooler, denser air is falling, right? But in the stratosphere, look, in the stratosphere, down here is cold, is negative 67 degrees Celsius, and outside here is warmer with that temperature there. So cold air is always trapped beneath warmer air, and is similar to what is called an atmospheric inversion inside the troposphere. Remember that? Talk about smogs and stuff like that. So because of that, there's no mixing of the air here as what happens here, and that is why the outer layer here is so, this area here is so stable that pilots and so on use that area there to operate. Mesosphere. Mesosphere means middle, experiences a decrease in temperature with altitude. There is little or no greenhouse gases present to absorb solar energy. Life would be impossible there. There's no air to breathe, too low temperature, direct exposure to UV. The only source of energy is what reaches from the troposphere below. Meteorites burn up in this region before reaching the Earth. And we talk about what the mesopause is. And finally, you have the thermosphere, which means heat. It has oxygen, helium, and hydrogen gases. Much of the solar energy is absorbed in this region before it reaches the rest of the Earth below. I hope that was useful to you to help you understand why you have all these difference in pressure and temperature changes in the various layers of the atmosphere. This here gives you a more detailed look of the troposphere and the stratosphere. So here's the Earth, and up to this region here is the troposphere. Okay? And you can see that all the gases, most of the gases are present here. Nitrogen, oxygen, carbon dioxide, water vapor is there, some different inert gases, and so on. Okay? And here you can see the temperature changes from 35 degrees closer to the Earth and to negative 65 degrees at the edge of the troposphere. And of course, this whole layer here is called the stratosphere because it's a layered region. That's what it's called. Stratosphere is a region of ozone here. Okay? And outside is the rest of the stratosphere. And as you can see here, as the UV comes into the stratosphere, it is blocked by the ozone layer present here. And because of that, you find that there's a mild heating up inside here. You can see two ways this gets heated up: by infrared radiation coming out from the side into that, okay, all right, from the troposphere, and the UV that is blocked by the ozone layer, and the heat is retained there. Okay, so that brings us to the end of the various layers of the atmosphere.